you could look back at this. Okay, so there are two coordinate systems. This is notes 412. So first is just rectangular coordinates x comma y. They give us a way to identify a location of a point in a plane. And the point 3 comma 3 is unique. So there's only one point where the x coordinate is 3 and the y coordinate is 3, and you put a dot right there. But polar coordinates give you the r value, meaning the radius, and an angle measure. And it gives us a different way to represent a location. The value of r is the distance, basically the radius the point lies from the origin, and the angle theta indicates the direction you would travel from the origin to get to that point. So you're going to travel 45 degrees, you're going to travel 135 degrees from the origin. So it's basically just an angle from the origin, just like we've been looking at in standard form. Theta is an angle, the ray from the origin that makes a point with a positive x-axis, and the angle is measured counterclockwise, like you know. Polar coordinates are not unique. So there's more than one coordinate that represents the same location, right? If I tell you an angle measure of 30 or 390 degrees, it gets you to the same spot. So there's more than one way to name the location. And why would we ever use polar coordinates? So if you were going to walk like a city block and you'd have to go 3 blocks to the north and then 3 blocks east, right? The polar coordinate really tells you kind of the hypotenuse of that triangle. How far would you walk from one point to the next as a straight line, like how the crow would fly? So how do you plot a polar coordinate? So I wanted to show you what polar graph paper looks like, but obviously, like for homework questions, you're not going to have polar graph paper, so just make your little, 90-degree plus sign as your axis and just guess where it would be. So this is different types of polar graph paper. So on this one, they're dividing up the plane into what, 30 degrees each time? This one's only dividing the plane into 90-degree quadrants. This one would be how many? So here's 1, 2, 3, 4, 5, 6 slices. So those would be each, I think, 15, right? There's 30, there's 60, there's 90. So each of these is a 15-degree slice versus a 30-degree slice, right? So you have to first figure out what type of polar graph paper you're looking at. So I'm looking at, these are all 30 degrees. And then each of these circles has an R value of 1. So if you have 3, basically you have a radius of 3, and you want to go 30 degrees from the origin. So from the origin, here's my 30-degree line. I'm going to count out 1, 2, 3. That's where that point A lies. So I'm on the 30-degree reference angle. And I've gone 3 of the circles out from the origin. Do you have this set of notes? Got it, Ethan? So B, what? Are you writing this down? So now I'm at 210. So if I'm counting by 30s, right, I'm at 180, so I'm at 210 over here, right? This would be 210. So now I need to go just 1 marker out from the origin, so I'd be way in here, would be point B. So just a different way of plotting points. Instead of plotting X and Y, I'm plotting an R value and an angle measure to identify a point in space. Does that kind of make sense? All right, so example 2. So now they want you to go a radius of 2 in a 45-degree direction. So you'd have to find your 45-degree direction, which would be up here, right? This would be 45. As you count 15, 30, 45. And I need to go a radius of 2. So from the origin, I'm going to count 1, 2 and put my point. So there's C. And I have to do 5, 300 degrees. So 300 degrees is what? 30 degrees more than 270. So it must be here, 300, right? Because I'm counting by 15s. So what does it say? 5. So I have to go from the origin, 1, 2, 3, 4, 5 about. So if you were going to do a homework question on this, you're not going to have polar graph paper. Just sketch it, As long as it's roughly where it should be, that's good. All right, so if you notice, those were all positive R values and positive angles. So you have to be careful when you have a negative R value because you're going in the opposite direction, right? You can't have a negative radius of a circle, but you can go in an opposite direction, just like an angle could open counterclockwise or clockwise. So a negative R value just means that you're going to walk in the opposite direction that you would have. So 100 degrees, that's where, about like this direction maybe, right? 10 degrees past 90. So I want you to extend that line kind of 180 degrees through the origin. So that should be a straight line. So this is my 100 degrees right here. And it wants me to walk -2 as my R value. So instead of marking the point 1, 2 in this direction, I'm going to start at the origin and walk 1, 2 in the opposite direction. So a negative R value just means to walk in the opposite direction that you would have. And then if I wanted to graph 2, 100, then that would be over here. Still on the 100 degrees, but in the positive R direction. So a -2 goes this way, but a +2 would go this way from the origin. All right, so example 4, now you've got a positive R value, but a negative angle. And whether it was positive or negative 180, you'd still end up on the same, like, opposite x-axis, right? Negative x-axis. So we're just going to go 4 units, 1, 2, 3, 4, and plot that point. So there's C. In D, they want you to go 180 degrees, but then they want you to walk in the opposite R direction. So I would go over here, but I really want to walk away from 180 degrees. So I would go 2 points in this direction, right? So I wanted to walk on 180, but I have to go backwards. So I'm going backwards a radius of 2. Does that kind of make sense what an R value and an angle tell you? That's all a polar coordinate is. So that's just the idea of plotting a polar coordinate. I think I'm going to stop that video.